Hello, everyone. Welcome to the third episode of the AI Healthcare Podcast. I'm your host, Reid, and today we are joined by my friend, Devansh. He is an AI and machine learning consultant. He's also a writer of Artificial Intelligence Made Simple and Technology Made Simple on Substack. Thank you for your time, Devansh. Really appreciate you hopping on.
Hello, Dylan. I'm very excited to be here.
Yeah. So, just to start off with, what motivated you to get into the AI healthcare field?
Sure. So, me getting into AI healthcare just happened to be a lucky accident. I was part of a team that Apple on the Parkinson's disease detection task, specifically when it came to low resources and the variables like that. So, we were able to create and commercialize an algorithm that had much better generalization and robustness, with robustness being the main reason why we got some attention. That was really the first thing I did. And because of that, I think I kind of got pigeonholed into the AI direction. And really, when I started off with it, I didn't know anything about AI. So the way I was experimenting with the algorithms of the models was that was one of the other people on the team. It was a team of three. So one of the others would either give me some inputs on like, look into this, look into that, or I would just Google stuff like, how do you improve the accuracy of this model, and then there'd be a bunch of discussions, and I just brute force try out everything.
Mhm.
So really, there was it was quite an accidental process of me getting into AI healthcare. But since then, I've worked with a few different teams and projects with it, most notably being with a state government in helping forecast the public health metrics.
And yourself coming from the engineering side of the industry, what is one area that you see the most opportunity in creating AI and large language models in the healthcare industry?
Hmm. Sure. I think when we really look at the data and look at what's been successful, what the use cases are, there are a few different avenues for AI and LLM specifically in the healthcare space. Of the language model side of things, and this would be stuff like helping at medical meetings, etc., acting as a medical scribe of sorts. So we have a doctor and a patient recording, and the LLM is just sitting there taking notes. This really plays strongly into the AI's wheelhouse because it just needs to listen and transcribe data, which is a problem that's relatively easier to solve. It's able to do all of this. It can doctor productivity. I know of people who are using the data from this area to also look into helping doctors fill out like all kinds of medical disclosure forms or whatever else they have to do. In all of these tasks where I guess the need for creativity, etc., is limited, and LLMs can really be used to improve the secretarial side of things, help people find information that they need from a hospital is another great area. So a lot of basically information is somewhere, and LLMs are either being used to transcribe it, or that can be a potential for great use. The second is going to AI in this is more general AI, maybe with disease discovery, that's with drug discovery, etc. This is where a lot of my involvement was. This part of the AI in healthcare space is time and resources. This is going to be a lot more computationally challenging. So clearly, not everybody is going to get into the space of benefit equally. But if whoever does win in this space is going to win big because they're going to crack really hardcore recovery protocols. That's going to help a lot of people. And thirdly, of course, we have the general operations side of things. So like slot forecast demands, improve your logistical operations as a hospital, etc., which a lot of organizations in other industries do. I don't know how prevalent that is in hospitals, etc., but that is the third side of AI. Again, not super. specific to LLMs, but just in general, using various AI tools to be able to run operations more smoothly.
And from your newsletter, Artificial Intelligence Made Simple, you talk about kind of the terms that really stuck out to me were speculative versus real risk.
Hmm.
So, what do those mean, and how has it made people become misguided about AI in healthcare?
Sure, that's a great question. So, as the names would suggest, what we see are there is a kind of risk that a lot of people focus on, that a lot of even respected media channels, etc. That's the kind of risk they push, because this is what's prominent and well known. And then there's the real risks, which are not so sexy, but these are the ones that are causing damage. So, as a more general example, we can talk about AI in healthcare, and we talk about, hey, the or like AI in information. The speculative risk that a lot of people love with LLMs is LLMs are going to be used to generate like mass information en masse and increase the polarization of society, etc. That's a pretty fun scenario to really take into extremes. Think about how people might end up like we might end up fighting wars because of LLMs generated proxy wars between Google and OpenAI, because different teams are using their LLMs to generate different things, etc. Really go all in on the sci-fi dystopia there. But when we really look at it, okay, sure, LLMs can be used to create misinformation, but is this misinformation going to be high quality? Probably not, based on generation metrics. Is it going to be new? Clearly not, because LLMs only generate what's in there. And thirdly, is LLM misinformation really the problem here? Is it not deeper systemic issues such as alienation, such as people running to these online spaces, not thinking critically, etc.? So that is the difference between a real risk and a speculative risk, where all of this is there. And then the real risk that we can go with misinformation is just this: people misunderstanding tools and misusing them. So I've seen so many people, ChatGPT, for example, going back to the healthcare space. They think, oh, we're going to use GPT as oh, I'm going to put all of these symptoms in here, and GPT is going to use these symptoms, etc., and it's going to generate a likely diagnosis, possible diagnoses, etc. One thing that you get when you start researching these models in depth is they are terrible with precision and reliability. So uh, the same output's gonna make them produce different answers, and sometimes they're they'll say I've done this one task, but when you look at the generation, they've done something else. And all of these together combine to create this really huge problem with LLMs, where you probably definitely want to be very careful before you start having them do prescriptive stuff, where you have them start automating away those parts. Or even when we going back to the examples earlier, you want to have oversights to make sure that they're not missing any information that you feed in, the information off the top of their own heads, which they are very likely to do. So these
Mhm.
are all risks that we need to understand, and people have been pretty much the GPT hype cycle. It's clearly been overlooked. It's like been trying to push this narrative that we can use GPT to do this, we can use it to do that, and when we look at the data, it doesn't really add up. Going
Mhm.
back to a more general look into AI, this has been a problem with AI as a whole, where people have been reckless in implementing stuff that doesn't really work out always. So we've seen this with healthcare, where people implemented an algorithm to be able to detect how sick a person was, and this detection is really hurting Black people, because the historical data they based it on, Black people had lesser money to spend on uh, their treatment, and they used the amount of money spent as a proxy for the severity of that disease. So what ends up happening is Black people, when they go in with the same prognosis, they have much worse to get the same level of like urgency treatment, which you're going to end up hurting. And there's other examples where people of different marginalized groups, etc., were uh, face these adverse consequences because of AI. So one of the things that I've tried to push, when other things I'm working both on and offline in like meetings and trying to get people to see is, hey, we really need to make sure that if we are using AI, if we are using machine learning here, you want to be able to study the data in much more detail. You want to make sure there's no errors. You want to make sure whenever it's using bias, wherever that bias is creeping in from a place where we're using it, because not all bias is not bad, but we want to make sure that the bias we use is in the helping something that's active.
Mhm. So would you say then that bias and transparency, is it more speculative risk or is it more real risk, or would you say it's both?
I'd say people like there's a speculative risk to it, there's a real risk to it. And again, it's one of those things where the speculative risk tends to focus more on the models and saying like, oh, this model's going to do this model's going to do that. The data quality and the data, where we once we start analyzing the data, we see that there's all kinds of hidden associations that AI can pick up and deep learning can pick up. These hidden associations can often link to demographic information. So in the healthcare space, maybe you want there to be some degree of demographics being factored into an AI's decision making, right? I'm My racial and health demographics are different to yours, are different to somebody else's, and that has to be a factor when you consider it to make decisions, to recommend treatments, etc. But on the flip side,
Mhm.
you also really don't want there to be a case where demographic information was used and you didn't know, or the medical practitioner didn't know. So this becomes like a hidden thing. So the transparency here becomes very key. And most of the speculations about these risks, etc., tend to focus more on, oh, this is gonna severely damage somebody. It's gonna tell somebody they had cancer when really they had a cold or something like that. That's the much deeper issue, is that it's gonna seem like it's working for a lot of people, but because of the demographic information that was taken in, etc., it's going to damage a certain group of marginalized groups. And because they're marginalized, that you're probably not going to give them immediate attention. It's not going to be as obvious, because if you're like only 5-10% of the population, it's going to be, it's much harder to get spotlight effect kicks in. You'll see the majority and assume everything is good. Or two, it's again using this information in decisions where it shouldn't. Maybe it picks up on a certain groups might have been privileged in the access to, starts to replicate that bias, and we don't know that it's replicating it, because it's this hidden association that it's picked up, that people didn't understand. That's a kind of, so with the same medical severity, will get treatment quicker. It's going to get an algorithm that determines urgency is going to put them lower than these hidden biases that it's picked up. So all of these are factors that you've got to consider when you're looking into implementing AI
Mhm.
in healthcare.
And where do you see the construction of AI models and large language models for healthcare in the near future?
I think construction of these models is not going to be a super big um, game changer, especially with large language models, just because most medical data is not language model specific. So I think a much bigger thing will be the products around these models. So with LLMs, you'll probably see an already existing LLM that's efficient, that can work real time transcriptions, etc. And then we're just using it in a, so that's maybe processing the audio better, helping you fill out more information from the forms, doing basic things like highlighting for you, etc. Second
Mhm.
thing is going to be general AI models. Most people, you probably don't need to be work to improve performance. Again, this is a very common example from, but this actually mirrors my own experience. you can like you can try improving your for a disease detection. You could really break the bank, tune it a lot, and you might get like a 4 or 5% performance improvement. Or you can go back, use a simple model, but really dig into the feature engineering, really do all of that, and you'll often see that this actually creates much better performance. So using higher quality data, higher quality jumps, you can like you'll get 2 times, 3 times better the 20% jump, 10% jump. These are all very feasible with this. So I don't think, again, this is one of those things where I was alluding earlier. A lot of attention gets put on the models, but very rarely are they the stars of the show.
Mm-hmm.
In again, going back to pharmaceutical drug detection and those kinds of tasks, which there's going to be a lot of money put into there, but there's only going to be a few good players in that game. It's not going to be every medical team is doing. Then
Mm-hmm.
the models themselves become bigger factors. They still will probably not overshadow the data you have, the processes you have, the entire pipeline you build, but the model there becomes a bigger star of the show. But for most use cases, it's more of a problem of building a good product around a simple model, making sure your data is high quality, making sure your inputs and outputs work. If you're using large language models, making sure that whatever input that comes into there is not corrupted in any way. They're getting the right signals. These are all generally a much bigger consideration for teams that are trying to deploy these solutions.
And what would be one particular policy area on the engineering front in AI and healthcare that Congress needs to understand?
So I've been pushing for this for a while, not just with healthcare, but in general for high sensitivity fields like finance, healthcare, employment. I think we need to start having AI audits. So we need to create a group that's going to go out, audit teams, audit things, because again, we need to make sure that when we're studying transparency, when we're studying data, somebody's out there making sure all of these processes get done. So more and more now we're starting to see people looking into AI transparency, creating metrics, creating these things. That's great to see. There was just this week, I think, we had this paper by Stanford and a bunch of other Princeton, a bunch of like it was a joint venture to evaluate the transparency of large language model companies to see if the processes were great. So more along those lines with healthcare specifically, they would focus very heavily on again what kind of checks have you done to make sure that your model is not picking up on any hidden associations? What
Mhm.
kind of things are you looking into? One of the examples I covered in my newsletter, which like really goes to show you how bad this thing is when we have uh, people took images of lungs and they said, "Do you think AI can predict?" They asked medical experts this. Do you think AI will from these lungs? Unequivocally, people said no. Actually trained and it's a fairly simple model to take an image of a lung, predict the race, a self-reported race. This is. It worked really well. 97, 98% accuracy we're looking at. People are
Mhm.
stuck there. This was then. Here's the really uh, important part. They corrupted these images. So they ran the noise to the point where these images don't even look like lungs anymore. They just look like random Gaussian noise. And
Mhm.
at this medical is no way AI can detect race from this. There are no discernible features. There's not even a lung. There's just random pixels on the screen. Like TV is like the static. This is what this is. AI about 80% something performance in predicting race. And this is after we've added this much noise. This is after they did things like taking only 1/9 of the original image. This robustness in any vision would be game changing. So the fact that they didn't use deep robustness there, but they're still doing this is massive. Now, what does this not mean? Is this a bad thing? Because if you're using AI to study something, who studies probably want to know what demographics they are. That's going to play a factor. So it
Mhm.
detecting the race itself. Why this becomes a problem is, what if this is not healthcare? What if this was somebody's credit score or financial history, and AI somehow was like, oh, AI could pick up this person and suppress their scores. What if AI there's a problem with resume detection? AI can often pick out if somebody's a woman, man, if they're from what their sexual orientation is, etc., and cut press those down. This is why employee productive using AI to rank and fire employees often turns so badly, because it ends up picking on people with disabilities, etc. Who are, but their metrics are generally calculated differently, and AI doesn't have the nuance to appreciate that, so it just goes in and does all of this. So,
Mhm.
in any sensitive AI healthcare, such as if there's all kinds of where companies are using AI to automatically rank employees based on productivity, financial decisions, financial evaluating somebody for a job. These are areas that can actually have an impact on somebody's lives. In such areas,
Mhm.
people should be there should be some starting implementing an AI algorithm in this. It gets audited by a third party, and there's like a group that you form and do this. This is something I've actually been trying to after years, not super aggressively, but a lot behind the
Mhm.
door. We've been having conversations about it. Something that we really need to start looking at, because we've seen
Mhm.
AI being trying to integrate AI is far, far more than the pace of trying to study the risks, etc. Like the pace of trying to
Mhm.
study the risks. What that means, people are often using these technologies, especially if you're not from a background that reads a lot of these AI research papers and knows a lot of machine learning engineering teams, actual machine learning engineers, what they have a great software engineer code. So they're able to deploy machine learning code really well, because they're like, oh, this is the code, this is how it works. But they haven't dug through the research, etc. So we need to have third party evaluations and audits. That's the one policy that I think, yeah, should, like Congress, politicians across the globe should. I don't think it's going to get
Mhm.
anytime soon, but that would be my hope.
Mhm. And where can people find more about you, Devansh?
So the best places to find me would be my AI Made Simple newsletter, or my LinkedIn, which is just Devansh. On either one, you will be able to see all of my other links. So I have a bunch of different social media links. I have that I have other kinds of content on Medium, etc. So either AI Made Simple or my LinkedIn, you get onto one, and then getting in touch with me through those is relatively easy.
Awesome. Well, thank you again and for your time, Devansh. Really appreciate it. Do not forget to hit the like button and subscribe to my YouTube channel. Podcast episodes are also available on Spotify and Apple Podcasts. And do not forget to check out my newsletter, the AI Healthcare Report, on LinkedIn. This is Dylan Reid signing off. Thank you again.